because usually if you have a lot of tans, you also want secs. Hey there. So today we are going to be doing this integral right here, and as usual on this channel you'll find integrals that look really complicated, and this one is pretty special. I mean, just look at it. You have tan and you have fourth power of tan inside a square root, but you don't have any secants to accommodate for that, because usually if you have a lot of tans you also want secs. I know that came out wrong, but I meant secants. So you also want secants because then you can do some substitution and maybe get rid of the tan and turn it into algebra. But over here you don't really have any secants. So I think we should go with sine and cos, because always you have two choices in doing trig integration, either tan sec or sine cos, or cot cosec if you're crazy, but we are not. So let's turn it into sine cos. So this will become sine by cos, so you'll get sine x, and by cos x we'll manage that later, and then we are basically multiplying by cos to the fourth inside, so you'll get cos to the fourth x plus sine to the fourth x. And then to handle all the cosines that we've multiplied it by, this will produce one cosine, this will produce two cosines, because cos to the fourth and its root, so you'll have cos cube, not theta. We are in x world. Okay, so that is what we get, and now I think it's pretty clear what to do. So previously we didn't have anything with which we can make a good substitution, but over here we do have some stuff. If we let u equal cos x, then this will actually simplify, because you have sine x, which is actually the derivative of cos x times -1, and this square root can actually be written in terms of cos entirely. So I'll show you how that can be done. So if you take sine square x plus cos square x, we all know that's 1, and if I square it, that is also 1, and this is sine to the fourth x plus cos to the fourth x plus 2 sine square x cos square x. And you can see we have this part and this part over here, so we can just say that this is equal to, this thing is 1, so 1 minus 2 sine square x cos square x. And if we put that in, and also we can use sine square x is equal to 1 minus cos square x, and if you simplify it, you will get 1 is 1 minus 2, 1 minus cos square x cos square x, and if you open the bracket, you will get cos to the fourth x times 2, and then minus 2 cos square x plus 1. So this is what goes into the square root: 2 cos to the fourth x minus 2 cos square x plus 1. Okay, so that's sorted out, and so you can see that if we put u equals cos x, then everything will get much better than it is now. It won't get too good, but it will at least get better than what it is now. But how about we, instead of putting u equals cos square x or cos x, we put cos square x, because that will help, because you can see you have a lot of cos square inside over here, and you may say that we'll run into trouble with this cos cube x. Well, to fix that, if you're going to put u is equal to cos square x, we need cos x over here for du. So we'll multiply and divide by cos x, so this becomes to the power 4. And now notice that this part, cos x sin x, is in fact half of dy dx cos square x, with a negative sign, of course. So once we put this in, this entire thing is minus half du, so we'll get minus half times du. So this part is sorted out and the dx is sorted out, and then this will become u square root of 2 2u to the fourth minus 2u square plus 1. And wait, we put u is equal to cos square x, right? So yeah, my bad, this will be square and this will be to the power 1. Okay, so this is what we get finally, and as you can see, I'd say at least it's much simpler. And now notice that we have 1 over u square. This is basically 1 over u square, right? And that is equal to the negative derivative, so not dy dx, dy du of 1 by u. So if we substitute, let's say some variable w is equal to 1 by u, then this is precisely sorry for that. This is precisely dw but with a negative sign, so we can use this negative sign up. So we'll get half integral of root, now this disappears, we'll get 2 by w square minus 2 by w plus 1 dw, because if w is 1 over u is 1 over w, you put that in and you get this. Okay, now what? So how about we just bring the w down, because we don't like fractions inside square roots that much. So this will become 2 minus 2w plus w square all over w dw. Okay, now what? So if you see, if we write 2 as 1 plus 1, then you have w minus 1 whole square. So this is half integral of root of 1 plus w minus 1 whole square over w dw. And now what do you do when you have root of 1 plus something square in your integrand and it's annoying you a lot? Well, you put this bracket is equal to tan x or tan theta in this case, because we've already used up x. So we put that equal to tan theta so that this entire thing becomes sec theta. So how about we do that? Because if we put w minus 1 is equal to tan theta, this is going to become much simpler. So let's put w minus 1 equals tan theta. So that implies w is tan theta plus 1 and dw is sec square theta. Okay, so let's put that in. We'll get half. Now this entire thing becomes sec, so you get sec cube theta over tan theta plus 1 d theta. Okay, so the good thing is we got rid of all the square roots first of all, but the bad thing is, how do we deal with sec cube? Like if it had been sec square, this would have been a really easy problem now that we've come to this stage, but it's sec cube. So how do we deal with sec cube? Well, let's get rid of this first and I'll be right back. Okay, so this is what we got so far, and now we don't know how to deal with the sec cube. So how about we break it into tan? We won't completely break it into tan because then we'll start getting the square roots again, because this is basically root of tan square theta plus 1 whole cube. So if we break all the three secs, if we break all the three secants up into tan, then we'll get the square root back, which is precisely what we were running away from. So we don't want that. So how about we just write it as sec square theta times sec theta, and then this can be converted into tan, because then we can save ourselves from the square roots. So this will become tan square theta plus 1 times sec theta over tan theta plus 1 d theta. Okay, so we have tan square plus 1 and tan plus 1, and they don't really divide into each other perfectly. So how about we add and subtract 2 tan theta, because then we can complete the square. So we get half tan square theta plus 2 tan theta plus 1, that minus 2 tan theta, because we are adding and subtracting, and that entire thing into the sec theta which is still there over tan theta plus 1. And now if you realize, this is just tan square theta plus 1, sorry, tan plus 1 whole square. So you'll get half tan theta plus 1 square, and then I'll break this up, sec theta over tan theta plus 1 minus, and then the 2 and half cancel out, you'll get minus tan theta sec theta over tan theta plus 1 d theta. Okay, now what? Well, first of all, this cancels out, which is awesome. And second of all, tan theta is not that far off from tan theta plus 1. So how about we make it into tan theta plus 1 minus 1, and then we can cancel it, tan theta plus 1 out from one factor, and we can separate out the minus 1. So we'll get half, and this is just the integral of tan theta sec theta. Wait, I forgot the d theta. Tan theta sec theta plus integral of sec theta. So integral of tan theta sec theta is just sec theta, and then sec theta is ln tan theta plus sec theta. Okay, and then wait, yeah, so we'll get minus integral of d theta, because no, wait, sec theta d theta, sec theta d theta, and plus integral of sec theta by tan theta plus 1 d theta. Okay, and now notice that this is actually the, so basically this is ln minus ln tan theta plus sec theta. So half minus 1 will give us minus half, so we can just do that because we are lazy, or at least I am lazy. I don't want to pull you into this. Anyway, so we have half plus, and now I'm going to convert this into sine and cos. So multiply by cos up and down, and you will get d theta by sine theta plus cos theta. And now recall an identity. This is in fact root 2 sine of theta plus pi by 4. Alright, yeah. So if we put it into that, this just becomes cosec. And now we are going to be crazy, and we are going to go into the cot and cosec world. So this will become 1 by root 2 because it comes out, and then integral of cosec of theta plus pi by 4 d theta. Okay, so now integral of cosec is, let me recall, ln minus ln of cosec of theta plus pi by 4 plus cot theta plus pi by 4. And one cool fact is that you can just bring this minus sign inside like that and not even justify it. So I'll leave that to you. Anyway, so we get half. So basically I can take half common, and then sec theta c, and close that bracket, and that is our answer, except we are no longer in the x world. But I'm going to leave that out because undoing substitutions, man, anyone can do that. The integration is the main part. I already did that. I hope you enjoyed it, and thanks for watching.